Hey-o! In this video, we're going to tackle solving exponential equations. I'm laughing hysterically because they're so easy. Honestly, it's a joke. It's how simple these are. So hopefully you already know how to do them, but we're going to cover them anyway. But they're really easy, trust me. All right. So what is an exponential function? Again, what's exponential mean? Okay, a function where the variable, typically x, is in the exponent with the numerical base is considered an exponential function. So if you have an equation, you have a 3 raised to the x, or a 4 raised to the x plus 5, or a 17 to the x minus 2, or a 2 raised to the x squared minus x. Those are all exponential because the variable is in the exponent. This is not exponential. It's quadratic, right? The variable is the base, okay? The 2 is a constant. It's always 2. It's not changing. So it's when the variable is in the exponent. That's exponential. Okay? When just because you have an exponent doesn't make you exponential. That's just a simple quadratic, right? So we're talking about the base being a numerical value, the exponent containing the variable. All right, so how do you solve one of these exponential functions? Kind of two ways we're going to talk about. One is to use the one-to-one property. The one-to-one property is an awesome property, right? It says if you have a to the x equaling a to the y, if your bases on each side are the same, then obviously your exponents are equal. I mean, they get out of be, right? I mean, if you have a squared equals a to the what? Well, it's got to be a square. I mean, the only way that a squared equals a squared is if it's a squared and a squared, okay? But be careful, all right? Because this property only works if the only thing on the left-hand side is the base of a with an exponent. The only thing on the right-hand side is the base of a with an exponent. It doesn't work if you have something like a to the 2x minus 3 equals a to the 3y. Okay, like you can't use the one-to-one property because of this minus 3 right here. You got to have both sides being a single base. That's the same, by the way. Got to both be a, and a exponent going on that has the variable. So the moment you throw in something else besides that base, you're in trouble. Okay. All right. So getting the bases to match up on each side of the equation can be tough at times. So that's the one issue. If your bases do not match up, like you got a 3 on one side, a 2 on the other, then all of a sudden the one-to-one property cannot be used. So it's a great property, but it can only be used in certain situations. The other thing you could do is to rewrite the exponential function in logarithmic form. Yes, this is called the inverse property. Remember, logs are inverses of exponents. So the inverse of an exponential is logarithmic. So one way that you can solve an exponential function is to use logarithmics, okay? Remember this rule. If you have a base raised to an exponent of x, and this equals, I'm just going to say w, right? Or you know what? Let's actually have it be a number, that way we don't get too many variables here. Let's say it's 5, right? So b to the x equals 5, and we say, okay, I want you to solve for x. Oh, how do you solve for something that's in an exponent? Aha, that's where log comes in. Use the definition of a log, right? A log equals an exponent. So it'd be log base b of 5 equals x. And what do you know? I just solved for x. I mean, that's how easy it was. Let's try one more. All right, if I have 3 raised to the x equals 21. And you say, okay, I don't know, 3 raised to what equals 21? I don't know. Well, what's x? All you gotta do is use the log property, the definition. So you'd say log base 3 of 21 equals x. And you know what? You're done. That's it. You could certainly use a calculator to figure out what log base 3 of 21 is. Go ahead if you want. I'm going to tell you right now, it's an irrational number. 3 squared is 9. 3 to the third is 27. So the answer is somewhere between 2 and 3, but it's going to be an irrational number. So I like exact answers. So I would just leave the answer just like that. Perfectly fine with me. All right. So again, that's where I'm talking about the exact answers, these approximate answers. Go ahead and grab a calculator. You can figure out what the answer is. In fact, I'll do it if you want to do it on your own. Feel free. I don't really care. Log base 3 of 21. It is, just like I said, between 2 and 3. It's 2.7712437449. but it's irrational. I don't like irrational numbers. I like exact answers. So be careful if I say, give me the exact answer, or I say, you know what, I'm okay with the approximate answer. Just round 2, 3, or 4, or 2 decimal places, whatever. So read the directions. All right, let's try this out here. Let's see how this works. All right, so we're going to say 2 to the x equals 32. 2 to the 1 equals 32. Now, listen, some people out there, maybe it's you watching this right now, are really, really smart. And you may say, oh, I already know the answer. 5. 2 to the 5th is 32. Done. X is 5. If you're that good, please do it. But if you maybe didn't know off the top of your head, again, how do I get an x in exponent to not be in the exponent? Use logs. Logs equal exponents. So log base 2 of 32 equals x. Then go and grab your calculator and you'll find out, oh my gosh, the answer is 5. 2 to the 5th equals 32. Easy, easy, easy. Now, check this out. I told you there's 2 ways to solve these problems. The one-to-one property and logs. Okay, so we use the log here, but check this out. I could have used the one-to-one property. What I could have done was this. I could have said, on the left-hand side, I have a base of 2. To use the one-to-one property, I need the right-hand side to also have a base of 2. And then you could say, all right, well, I know 2 to the 5th is 32. So I just literally just rewrote 32 as 2 to the 5th. And now I can use the one-to-one property. I say, oh, the left side's got a base of 2. The right side's got to have a base of 2. And that means the exponents must be equal. Oh my gosh, x equals 5. So you could use either one of those methods. You're going to get the answer, but they both do work. All right, let's try this one out. So again, I could use logs. And I could say, all right, so log base 1/3. Yeah, you could have a fraction base. There's nothing wrong with that. Of 9 equals x. Then you can go to your calculator. It's going to be a little bit tricky to type this one in. Not going to lie. But you could do it. It's a little weird, but you could do it. And you're going to get the answer as -2. Oh, wow, didn't know that. -2. Okay, great. Easy answer. Or you could have done this. You could have said, all right, I know 9 is 3 squared. And then if you're really smart, you could say, I know 1/3 is 3 to the -1. What? Yeah. Remember, negative exponents don't make you bigger. Negative exponents don't make you negative. Negative exponents make you smaller. Remember, n to a negative exponent, all that does is make you a fraction where you go to the denominator with the positive exponent. So 3 to the -1 simply tells me that to put the 3 to the 1 in the denominator, and I know 3 to the 1 is 3, so I'm just going to leave it as 3 to the 1, which is 1/3. So maybe you saw that, but wait a minute. 1/3 is 3 to the -1. I still have to raise it to x. But now I could use a property of exponents. Power raised to a power, you multiply. So that's 3 to the -x now equals 3 squared. So now I could use the one-to-one property. I got the left side to have a base of 3. I got the right side to have a base of 3. So -x equals 2. Divide both sides or multiply both sides by -1. And I get x equals -2. The same answer I got over here. Bottom line, I got the same answer. Don't care. Just get the answer. All right, let's take a look at this one here. Now, first thing I notice is on the left side, I do have a base of 2 raised to the x. I also got this multiplying by 3 hanging around. Well, listen, just go back to some basic algebra. Let's handle that first. I know how to get rid of multiplying by 3. Divide both sides by 3. I don't need to be told that or shown that. That's easy. So 2 to the x equals 14. Now, I'm going to tell you right now, one-to-one property's out because I cannot think of any humanly possible way to write 14 with a base of 2, with whole numbers at least. So I know 2 squared is 4, and 2 to the 3rd is 8, and I know 2 to the 4th is 16. So 2 to what is 14? I don't know. So I unfortunately can't use the one-to-one property here. I'm going to have to use logs. No big deal. Logs equal exponents. So it's log base 2 of 14 equals x. There's your final answer. That is exact. That's the exact answer. If you want to go ahead and grab a calculator to get the approximate answer, I mean, honestly, I'd encourage it, but depending on your assignment, read the directions to know what it wants. But the answer approximately to 3 decimals is 3.808. And you know what's other kind of cool is you can actually check your work if you want. Like here, I'm actually going to bring up my calculator and show you real quick here. You could do 2 raised to the 3.808. And I get pretty close to 14. It's not exactly 14 because remember, I rounded that 3.808. So that's why. So just be careful. All right, let's try a natural log. Oh, but wait a minute. I don't need the logs for this. One-to-one property. Left side is a base E, right side is a base E. So I can use the one-to-one property, right? Both bases are the same. That just means the exponents have to be the same. And now this is no longer exponential at all. It's just a quadratic. I'm going to get everything on the right-hand side because I want my x squared to be positive. So I'm going to add it over. I'm going to attempt to factor this. I hope it factors. If not, I'm going to have to try something else. Complete the square, quadratic formula. We'll figure it out. But let's see here. 2 and a 2 is not going to work because it's not going to get me a 3 in the middle. Let's try a 1 and a 4. Make the 4 negative. Make the 1 positive. Yeah, I'm pretty quick at this. And hopefully by now you should be too. There's the x squared. There's the negative 4 in the back. Outside's a negative 4x. Inside's a 1x. That makes the negative 3 in the middle. Therefore, x equals negative 1. X equals positive 4. Come on. Easy. Love it. All right, now here's another one. But again, be careful with this one. The base is E, the exponent is x. So a lot of kids panic. That 5 has nothing to do with any of the exponent. The 5 is just an addition of 5 next to the base and the power. So just subtract that over. E to the x equals 55. And then once again, I can't use the one-to-one property because I have no idea how to write 55 with the base of E. Don't sweat the small stuff. Just use the logs. So I'm going to use natural log because a natural log is base E. So natural log of 55 equals x, and I'm now done. If you wrote log base E of 55 equals x, you're still technically right. We just use log base E as this natural log ln, which is a little faster to write. Let's try another one here. And the first thing I'm noticing is I got this plus 10 I need to move over. I got this 4 I got to move over. The 3 is the base. The 2x minus 5 is in the exponent. So I got to isolate this part, right? Isolate the exponential part. So divide or subtract the 10, and I'm going to, you guys, come on. You guys are quick. You could do this. That's 40, right? Then divide by the 4 and get 10. So we have 3 raised to 2x minus 5 equals 10. You know what I mean? I know you guys could do multiple things quickly in your head. Subtract the 10 gets you 40. Divide by 4, you get 10. Now, okay, can't use the one-to-one property. You could only use the one-to-one property if you have the same base. I cannot write 10 as base, 3. If this was a 9, well, 3 squared. Then I can use the one-to-one property, but not with the 10. So I got to use the logs, right? Logs equal exponents. So this is log base 3 of 10 equals 2x minus 5. Now, at this point, I want to be crystal clear that this right here is a number. It's just not a very nice number, but it is a number. It's an irrational number. You can go to your calculator right now and figure out what log base 3 of 10 is. It's going to be some decimal. But understand that it's a number. It's no different than 5 or 6 or 22. It's just not as pretty, but it's still a number, right? Like human beings. We're not all pretty like Zac Efron. I mean, he's gorgeous. But, the point is that, he might be a perfect 10, and maybe I'm a irrational 1.629436. Whatever. Still numbers, my point. But to solve for x, I got to add 5 at some point. Now, I have no idea off the top of my head what log base 3 of 10 plus 5 is. Like, if this was Zac Efron and it was a perfect 10, well, 10 plus 5 is 15. But it's log base 3 of 10. Okay, log base 3 of 10. I don't know what it is. I certainly don't want to approximate it in the middle of a problem, so I'm just going to kind of leave it. Some kids like to put in parentheses. That way they're crystal clear that it's a number all by itself that you have to add 5 to. And then again, I got one more step left, and that's to divide all of that by 2. And then I will get x. So my final exact answer is kind of ugly, but it's just a number. Log base 3 of 10 plus 5 all divided by 2. That's it. You can't divide the 5 by 2. You can't divide the 10 by 2 because it's all inside this log thing, right? So it's an ugly answer. It is what it is. You can use your calculator to approximate it, but that is the exact answer right there. All right, let's do one more here that got really ugly. It's got some decimals. No big deal. Got to move the 148 over. Got to divide by the 4. Got to isolate the exponential part. Okay. So unfortunately, I'm not that great at math. So I'm going to go ahead and use my calculator. 205 minus 148 is 57. So let's see here. And then 57 divided by 4 is 57/4. It doesn't give me a nice answer. So I get 1.025 raised to the x minus 3. So just want to be clear what I did right there. I subtracted the 148. I then got 57. and then I divided it by 4. 57 divided by 4 is 14.25. I mean, 14.25 is an exact decimal. It is a terminating decimal. So if you would like to leave it as 14.25, I'm okay with that. That's fine. But now, again, I got this ugly base, but ugly bases are still bases. So I still got to just simply say, hey, logs are exponents. So get ready for this, but it is what it is. Log of 1.025, yeah, that's a base, baby, of 57 over 4 equals x minus 3. Okay, now, talk about beautiful numbers. This is not one of them. This right here is a number, log base 1.025 of 57 fourths. It's a very ugly number. I mean, if you want, go to your calculator, man. I mean, you could do this on your calculator. It's like I said, it's not going to be nice. But at the end of the day, it's just a number, right? I mean, it's just an irrational number. It's 107.5931879. It's just a number. And now I got to finish this off by adding 3 to each side. So my final exact answer, as ugly as it is log base 1.025 of 57 fourths plus 3 equals x. I mean, that's my answer, right? You could go to the calculator, approximate with the decimal, and then add the 3. It's about 110.59, but hey, it is what it is. And you know what? I'll be honest, in the real world, usually things get kind of ugly when you're going to need your calculator. This is actually stemming from a real world problem that we'll learn about later. But at the end of the day, you just got to be able to solve it. You got to understand the math behind it. And then you can always go to your calculator to get an approximate answer if you need be. All right, that's it, guys, for solving exponential equations. Seriously, I love these types of problems. They're pretty easy as long as you follow the rules. All right, enjoy.